Thank you for tuning into Dino Insights. In today's episode, Mike and Chris describe the development of a unique dynamometer system for testing lifeboat engines.
So I was just thinking about the next podcast and what subject would be interesting. And I remember an application that you came up with some time ago. Perhaps you'd like to introduce the marine solution we developed.
Yeah, that was a pretty cool application. We worked on it for quite some time, but how it evolved was the unique part of it all. The customer approached us with a unique application, to say the least, and we had to put together a plan of how to address their requirement. And the requirement was pretty unique. It was a lifeboat application where they wanted us to be able to load the engine in situ, which means basically the lifeboat's in its normal holding state on a ship or a vessel or a platform, and we need to be able to test the engine or provide load to the engine on a reoccurring basis throughout the year to make sure the engine operates properly once it's dispatched.
I believe this is the lifeboat which can't be launched and retrieved, so it's got to be tested, as you said, on the platform, but run for a period of time without any coolant or without any special equipment?
Yeah, that was the goal. I mean, there were some minimum requirements, right? So there was what I call monuments that you can't move. There's no wiggle room. And one of them was you cannot modify the existing vessel in any way, shape, or form as a permanent change. You have to utilize what's there. You can't drill extra holes. You can't do things that alter the boat in any way. It's an in situ application. So like you said, if they had to, the only other way they would have to do this is they'd have to lower the boat into the water, and then they'd have to start it up, and they'd have to run it around in the water, then bring it back, pull it back up out of the water, put it back in its mounting location. They'd have to do that multiple times a year, which logistically, let alone expense-wise, cost-wise, labor-wise, would have been, obviously, for them, is not a doable situation.
Well, I think it was actually more difficult than that, because it wouldn't be possible from some of the launching stations that we've seen. Learned quite a lot about lifeboats through this project. But the lifeboats can't be recovered. I mean, they're launched literally in the case of emergency. They're launched from the platform into the water and then have to navigate themselves away. So we needed to test the engine to make sure it would perform from zero as soon as it dropped in the water.
Right.
So the ability to test this, as you mentioned earlier, in situ was critical to this being a viable solution in the case of these lifeboats, because it's a one launch only situation. So I think the interesting part from our point of view was how to address the problem of dealing with the lifeboat hanging from its launch point.
Right. And again, not everybody, most people don't experience going in a lifeboat, obviously, for good reason. But when you're inside of one, you can imagine that it's basically an engine in the center of this lifeboat. It's below, if you crawl inside a lifeboat, you sit on both sides, either side of the engine, which is mounted down lower into the boat. And what they needed us to do is come up with a solution to be able to load this engine. And obviously we manufacture dynamometers, so we had looked at different means of how to do that. But some of the requirements were, it had to be portable. You had to be able to bring whatever this device is that we could come up with and carry it to the boat, put it in the boat, install it in the boat, and not modify the boat in any way. Connect it, load it, and then remove it. And 3 months, 4 months later, they do it all over again. So that was one of the requirements. The other one was...
well, if I may, Mike,
yeah,
and that was one of those, because on a platform like an oil rig or a ship, there may be 20 of these. So I guess they could use the portability of this to move around between different lifeboats. Each of them could be tested in a sequence and develop a program of maintaining the engine performance really across the whole little fleet of these that exist on a ship or a platform.
Right, right. And again, the challenge is that when we originally looked at it, there was the understanding that it's a specific boat, a specific style. But even within that, we noticed that there were changes, or the dimensions weren't exactly the same as far as how it mounts. So we had to make this adjustable to fit within reason to certain boat model styles with inconsistencies potentially that we had to adjust for. So whether it be just up and down or side to side, to allow that capability. So that was one of the other things that we had to incorporate into this system.
So perhaps before we talk about how we extract the drive from the engine and gearbox in these lifeboats, perhaps you could describe how the dyno was mounted and how that was situated in the lifeboat.
Yeah, and again, when we talk about systems and engineering systems and utilizing our dynamometers in different applications such as this one, it wasn't success right out of the gate. We came up with a potential solution, a type of dynamometer, and that dynamometer didn't work out the way we wanted it to, so we had to change direction. But as far as the mounting of the dynamometer itself, it's something that basically from a high-level description perspective, it sits above the engine, the dyno. It has a set of bearings and a pulley that runs a belt down to the crankshaft of the engine. So basically what we did is we created a pulley to mount. You would disconnect the transmission from the engine shaft, and then you would connect a pulley so it would adapt to our dynamometer. So you had a long belt that engine drove the dynamometer.
So that helped us move the drive from the engine drive shaft to a more accessible position where an operator could test it with our dyno, understand the performance that engine could make over a short period, and just verify that it was running correctly.
Right.
Yeah.
Now add additional requirements to it. Add that you only have 110 volt power. So whatever you're going to do, whatever we're going to design, it has to be able to work off 110 volt power, and also a water limitation. So it can't be anything larger than a garden hose output. So we had to select and make sure our dynamometer was capable of running under the water pressures that they had on the vessel.
And having started with a self-contained sort of electrically based machine, we found that couldn't cope with the torque of this engine. So we transferred to one of the smaller water brakes, which could run from a garden hose, which is accessible on the platform. And found that would successfully absorb the power of the engine.
Right. And again, it was pretty unique. It's not like you went to a catalog to pick these parts out when we designed this. This was custom designed and to our requirements through our engineering team to put this together. So you can't go to a McMaster car, for those who know a McMaster car catalog that has industrial components, and buy a pulley off the shelf or buy a belt off the shelf. We literally had to work with torques that were pretty extreme and belt tensions accordingly, with understanding how much a cogged belt could take or needed to take for this application as far as torsionals and torque.
And in this case, did we have I don't think we needed to have any particular data acquisition for this. It was really just a verification that it met a certain performance level, and that was sufficient for the test.
Yeah, when it comes to controls, this is about as simple as it gets, Chris. You've got a valve, a physical mechanical water valve that you open to a certain position to provide a certain load. And then from a data acquisition, there really is no data acquisition. Basically, we provided a display that gave you RPM, torque, and horsepower.
So in fact, in that respect, a relatively simple system, but I can imagine that having the long drive belt introduces some additional issues into the system.
Yeah, the engineering challenges weren't with the display system because that's already been produced, right? And the dynamometer itself is already being produced and has been produced before. It's the application or the mechanical apparatus around it, which was the uniqueness of the whole thing. It was taking a standard dyno and putting it into a different application that it's never seen before. And that takes quite a bit of engineering work to accomplish.
So quite a unique application, but in some system sort of point of view, it's similar to doing any test system where you've got to look at the unique requirements of that test article and its environment to come up with a combination of a test and testing equipment, instrumentation, etc., that deals with that particular issue.
Yeah, exactly. And I think this is one example of many, but one example that illustrates when we talked in earlier podcasts about asking the right questions or asking questions for choosing a dynamometer, for example. This is not just asking questions about the dynamometer or asking questions about the engine that you're testing, but it's also the application. So you ask a lot of other questions, such as water supply. What are our constraints, like we talked about earlier? Are there constraints with electricity or water supply under the circumstances? Is there constraints with how much it weighs? Is there a constraint with space in which it's getting installed? there's a lot of things you need to ask to properly engineer and design a solution.
To get a true picture of the environment it's going to operate in.
Right.
Yeah.
And the customer was quite engaged in this whole exercise. So we made trips out there. We were on the boats. We took measurements. We went back and forth with prototypes, and it was a win-win situation, I think, ultimately.
And certainly an interesting looking test system when you see it packed up in the packing case ready to go to the customer. It's quite a unique layout that we have there.
Yeah.
Looks good.
Yep, absolutely.
But I suppose the end result is we've saved the customers, the lifeboat users or the vessel users, saved them a lot of time in testing this equipment, making sure it's ready to go, and effectively providing them with the certification that the engine will operate correctly in the unlikely and unfortunate case if it needs to be used.
Yeah, we definitely met the requirements, and I think they got some additional benefits at the end of the day. So we were able to provide a system that gave them a little bit more than I think what they were expecting. And I think ultimately for however they're using the equipment and whoever they're communicating with, if there's governing bodies that they have to certify to, we've given additional devices to help give them more information than they originally needed to help communicate this. So,
yeah, well, as you mentioned earlier, it was a lot of communication back and forth with the customer to define those requirements and to see how, as the solution developed, see how well it fits with those expectations.
Yep. It was a cool job. It really was. And it lasted, and I know before the podcast we were talking about when it started versus when it ended, but when you start something like this that's going to go into a limited production run, it takes time. It's not necessarily that you turn the corner in 3 months and you have a product being produced. So this, from inception to where we produced the first 5 systems, how long would you say that was, Chris? How many years?
I'd say it was about a year and a half.
Yeah. It didn't go without hitches and issues to be resolved, but that's part of teaming up with a good application engineering firm that understands their product, and understands the different applications it can be used in. And when you put your mindset to it, I would think that there's not many companies that would have took this challenge on the way that Froude did.
Yeah, certainly a good result and a good effort by the engineering team. Thanks, Mike.
You're welcome.
Thank you for listening to Dyno Insights presented by Froude. If there are any engine testing topics you'd like us to discuss, we'd love to hear from you. Please email us at podcast@froudedyno.com.